All right, here's the topic. And these things are really equations, one for zero, first and second order, respectively. And our goal is when you see them, I want you to know what they mean and what all the variables are and yada, 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 and why they're written the way they're written. I want to talk briefly about a graph that you know well and an equation for that graph really well. All right. You know, this is the slope intercept for any linear line. It works for that one. It works for this one, even though the m and the x drop out, and it works for this one. All right. That's because this relationship, it means different things in each of those equations, but it means in general, it means the same thing. All right. And this is what it all means. All right. And the reason this is important, because if you look at, if, if you remember and look at these linear relationships for each order of these reactions, there you're then therefore you can deduce that I can represent all of these with this general relationship. All right, the slope intercept form. And the slope intercept form is going to mean something in general, the same thing in all of them. Your x value is going to be your time variable. Your m is going to be your slope of the line. It's going to be your reaction constant. Your b is going to be your initial concentration. And your y is your concentration at a certain time. All right, there you go. Now this is going to apply to all three of those graphs on the last slide. It applies to all three of these, okay? Now I want to look at this equation just to really make it clear. So here is my y value. Here is my x value, my slope. Here's my y-intercept, and here is my x value. All right. Now I want one last thing I want to talk about is how they're written on the reference sheet for the AP exam. Here you'll notice that they've brought their y-intercept value over. And I believe they're doing this. So here's the way it looks there. They're doing this, I think, because it's like a change. Your concentration T is sometime after your original. Therefore, it's kind of like a change in your concentration. The left side of these equations is kind of like a change. That helped me remember and understand what the T and Z sub naught meant. So here are the equations for the respective orders. This is for zero order, and that's because the linear relationship is just the concentration. First order, it's the natural log, and second order, it's the reciprocal. All right. Now, these equations, the variables all mean the same thing. The A sub t is your concentration at a given time. Your A sub 0 or A sub naught is your concentration original or initial. Your t is your time, and your reaction constant is a k value, or your slope of the line is your rate constant. Now, the left side of these equations, I like to look at it like final minus initial, but it's really a time concentration. And if you look here, this is not a typical way to write like y minus b equals mx is the way they've written this linear relationship. But that's to me, I think they've done this because these are like a change. All right. It's not exactly a change, but it's like a change in concentration. All right. Thank you so much. And here are my sources. I hope you are doing well. Bye.